Hello and welcome to Physics Basket. We are going to cover today class 9 topic 12 and we will continue with motion problems part 2. So let's get started. So let's start with the first problem, and the problem says that the position time graph of an object is shown below. So this is the position time graph. Position is on the y-axis and time is on the x-axis. The displacement, or what we need to find is the displacement of the object in 7 seconds and the distance covered by the object in 6 seconds, the displacement of the object between 6 to 7 seconds, and find the displacement and the distance covered by the object in 10 seconds. So these are the points. So let us have a view of what the points are. So t is on the x-axis, so which means that at time t equal to 0, the position is -5. At time t equal to 3, the position is 0. At time t equal to 6, because x-axis is time axis, so time t equal to 6, the position is 3. We can see the y position, y is indicating the position, and time t equal to 7 on the x-axis, we have the position again on the y-axis, nothing but 3, which means that between 6 to 7 the position remains the same. So at t equal to 6 the position is 3, the t equal to 7 the position is 3 again. Noted. And then at time t equal to 9 the position is 1, and time t equal to 10 the position is finally 0. So what is it asking is to find the distance and displacement at these different times. At 7 second, distance covered by 6 seconds, the displacement between 6 to 7 second, and the distance and displacement of the object in 10 seconds. So as we know, like, distance is a pure magnitude. It doesn't depend on the direction. Whereas in case of a displacement, we consider, or we are concerned about the direction. So in case of distance, we will always be looking for the magnitude of the total position changes. So position changes between two different points. If we find out, like, this point to this point, or this point to this point, between this to this point, so we can keep adding, then we will get the distances. Whereas in case of a displacement, it is basically the final point and the initial point. So if we are asked to say find the displacement between time t equal to 6 between and the starting point t equal to 0, then it will be basically the final displacement position, which is 3, and then the initial position 5. So directly we can just uh, final position minus initial position we do, and then we get the displacement. But in case of a distance, we need to add up each intermediate points and then find out the total distance covered for its individual journeys across each of the path it has gone through. So let us look at it, how it has been done. So displacement in 7 seconds. So that is what. So we have just given the names to each of these points. So in 7 seconds. So what is 7 seconds? 7 seconds is here. So at 0th second, we have initial position is -5. Already we noted. So 0th second is -5. And this is the initial position. And at 6th second, so by the end of 6th second, we have the final position is 3 meter. So this is a 3 meter is the position. So the displacement will be final position minus initial position directly. So we are not concerned about the individual journey or intermediate journey. So we directly say 3 minus -5. So we get, so x final, the final position minus the initial position, and we get 3 minus -5, 8. So this is our answer at the 6th second. Between 6 to 7, again we can calculate, but 6 to 7 is again 3 only. So at 7th second, the displacement is same 3 minus -5 only. 7th second, the displacement is 3 minus -5 only. So this is nothing but equal to the displacement at 7th second also. Okay, so this is the answer. So 6 second, whatever is the displacement is same as the displacement is 7 second. So let me erase this. And then we need to find the distance covered in 6 seconds. So distance covered in 6 seconds is we are going to respect the individual or intermediate journeys here. So what are the intermediate hop points? The hop points is it has gone from A to B and then B to C. So we need to find out, okay, what is the distance it has covered when it has reached B? Position B minus position A. So 0 minus minus 5, then we get um, this one 0 minus minus 5, and then we do 3 minus minus 3 minus 0, so we say 8. So we get the same displacement distance also in this case. So distance is 8. But the thing is, we should consider the individual intermediate points. That will be more evident when we try to find the distance and displacement at some other points also. So in this particular case, we have same distance and displacement by the end of 6 second. Of course, by the end of 7 second also, the distance and displacement will be same because the position is not changing. So we have already answered for 7 second, and already we know by the 6 second also. So displacement of the object between 6 to 7 seconds. So between 6 to 7 seconds, the position is not changing because it was 3 and then it is 3. So we can simply say 3 minus 3. That means it is equal to 0. So the object was basically at rest. So the time changes, but the position doesn't change. So it was basically at rest. Now going over to the final one. So we need to find the distance and displacement by 10 second. So for 10 second, for displacement, we can simply say the position, final position at 10th second minus the initial position at 5th second. So as simple as 0 minus minus 5 is what we get the displacement by the end of 10 second. So it is as simple as that. So this is what we get. But when it comes to distance, as we already know, we need to respect each of the individual journeys or intermediate hops it has gone through. So in that case, we'll need to find out each of these values. So we'll say already we know till this point. So directly we are doing 5. 0 minus 5 is first point, right? So 0 minus 5 we have done, and then 3 minus 0, and then again we have 3 minus 3, so it's fine, it is 0. This point we can directly take this because this is a straight line, it's not changing, or we can say individually also 1 minus 3 or 3 minus 1 because um, always the displacement is positive, it will be a positive value, it will not be negative. So 3 minus 1, or directly we can say 3 minus 0, 3 minus 0. Here we have added 3 minus 0 directly. All right. So this is the 3 or 0. Or to be more precise, we can say plus. First is we'll do between this to this point. So it is nothing but 3 minus 1. Sorry. 3 minus 1. That is one thing. And then plus we will do, instead of 0 minus 1, we'll say 1 minus 0 because distance is always positive. Distance increases. It is not dependent on direction. If we say minus 1, which means that we are considering direction. So displacement is like mod of the whole thing. So it's a positive value. So we'll say 1 minus 0. So this is what I've done together. So instead of that, every hop point we need to take care. So it will be 3 minus 1 and then 1 minus 0. So this is what it gives. Finally, it will be 11 meter. So the difference we can see straightforward that the displacement by the end of 10 second is 5 meters, whereas the distance is 11 meter. So let us start with the second problem. It says that the velocity time graph of an object is shown below. So this is the velocity time graph. We need to find the displacement of the object and the total distance covered by the object by 4 seconds. This is 4th second, and by 8 seconds. This is 8 seconds. So what we are seeing is the velocity is by convention, of course, it is on the y and the time is on x, and then at 0th second, 2nd second, 4th second, 7th second, and 8th second, it has different velocities, right? The velocities are at 0th second, it is 5, right? This is 5, it is not 6, it is 5, and it is here, it is 2. At 2nd second, the velocity is 2. 4th second, the velocity remains constant, again, it is 2. At the end of 7th second, it is almost at rest, and then it's a negative velocity, so it would have changed the direction or something. So by 8th second, it is minus 2. So again, going back to our basics, the distance will be magnitude or sum of all the distances, and whereas in case of displacement, it is direction. Now, velocity time graph, what it indicates, basically the area under this velocity time graph would indicate the distance or the displacement. The difference will be whenever there is a negative direction, the displacement uh, need to be considered with respect to direction, whereas distance doesn't matter. So irrespective of direction is positive or negative, distance always keeps on adding. So it's an incremental between different phases of the movement of the particular object. So first thing is, let us look at 4th second. What is the situation? Fourth, this is the 4th second, and this is how it is. So if you draw this, put the different points here across. So A, B, C, D, E, F, and 4th second is this one. So in this area, if we find out, then we'll be able to find the distance of displacement. The total area under ABC. So we can divide this into different smaller parts. So ABH being a small triangle, and then BCIH is another rectangle, and then we have AIGF is another rectangle. So these respective areas, if we are able to find, then we'll be able to find the distance and displacement in this case, because the whole velocity thing is positive, so it would be same for both. So what is the area? Basically half into perpendicular into base. So in this case, it's 8 minus 5. So 8 is the velocity here, and 5 is the velocity by the time that t is equal to 0. So 8 minus 5. So half into 8 minus 5 is 3, and then this is 2. So half into 2 into 3, and then this is 3 and this is 2. So multiplication of the sides in the case of a rectangle, so it is 2 into 3. In this case, it's a bigger rectangle, so multiplication of the sides are, this is 5 into 4, 5 into 4, so 5 into 4, so we get 29 meters. So this is the displacement and the distance, that is by end of 4th second. Now what we need to find is by 8th second. So 8th second, we have seen a slight change here. So first, by the time 0 second, it is 7, the velocity is 7. By the time it is 8 second, the velocity is 2. So again, let us consider these additional triangles. So till here we have already found it is 29, so no need to recalculate this again. So in case of displacement, again we need to find the total area across different triangles. So first let us find this triangle. So this triangle, if we find, it will be area under C, G and J, or C, J, G. And in case of displacement, since the velocity is going negative, we need to take care of the direction as well. So we will negate this part. So we will remove this from the total area that we find. So 29 plus this area minus this area would be our answer. So 29 plus this area is 8. This is total 8, and this is 3. 7 minus 4 is 3. 7th second minus 4th second, so this is 3, and this is again 8 to 7 is 1, and minus 2 is 2. So this area we have removed, and then we get 40. Whereas in case of displacement, in case of distance, we are not going to negate this area, because this is the additional distance that the object has covered basically. So we will still recalculate this area and add it to the previous area. So it will be 29 plus this half into 8 into 3 plus this one, because this is getting added. So distance is always incremental, as we know. So we will simply add this part and try to find the distance in the 8th second. So sum of all the areas in this case, irrespective of the velocity is changing from positive to negative, direction changes, all those things doesn't matter for us. So these are the different areas, respective areas. We already know these areas, so we just need to change this from negative to positive, and then we add it and we get 42 meter. So that is our answer for distance and displacement in 8th second. So let us take the next question. It says that, let me take the pointer. So it says that the tap, which is 5 meter above the ground, regular drops of water are coming down, and the third drop just leaves the tap at the instant the first drop touches the ground. Okay, so the drops are falling in continuous interval. By the time first drop is touching the ground, which is actually 5 meter, right? So 5 meters is the height of the tap above the ground. And by the time the third drop just touches the ground, we have the first drop coming out. And find the distance of the second drop from the ground at that instance of time. And we need to assume that J equal to 10. Okay, so what are the things? The height H we know already 5. First drop has already started and third drop is starting by the time the first drop reaches the ground. So what we need to find out is, we know height and we know this one. So first thing is, whenever a drop is coming out, right? So the initial velocity will be 0. That is known, and G is 10. So half GT square is the distance covered. So nothing but the distance covered 5 is equal to half GT square. So from there we can find the time the third drop or a drop basically takes to reach the ground. So let us draw a diagram first. So this is the situation here. Third drop is here. First drop has already reached the ground, and then third drop is just coming out, and this is the distance. So if we find the total time taken between these 2 points, so if you find this 2 points, the time taken, then we will know that by the time first drop has reached, it has covered this amount of time. And since each of the drop are starting at equal interval, which means that second drop would have traveled for half of the time that it has taken, right? So first drop has fallen fallen for t second. The second drop would have fallen for t and half second, and third drop is just coming out. So that is the situation here, right? So finding t is quite easy. So the second drop is somewhere here. This is the second drop, and we need to find this height, second drop, and this is the height the drop is above the ground. So for the first drop, if we find the time, which is as simple as, we know that distance covered h is equal to half gt square. So I've taken s here. U is 0, of course, because the starting point, the velocity is 0. And then we have s equal to half gt square, and then since g is 10, then we can get t equal to square root of 2s by g or 2h by g, and we get 1 second. So this is the time. So by the time it has covered 1 second, the second drop is midway somewhere here, right? So which means that second drop has traveled a time of t by 2. It has used t by 2 seconds, nothing but 0.5 second. So 0.5 second it has dropped from the initial position. And third is just starting, means it is at t equal to 0. It is just at the 0th second. This is at 0.5 second. Now, doesn't mean that it has just covered half of the distance, right? Because we have to again calculate from the distance time formula. So with that, in case of this, again, since the initial velocity is 0, so the second drop will be half gt square, which is nothing but half into 10 into 0.5 already we know. So 1.25 we get. So half u is 0. So we get 1.25. So this distance is nothing but 1.25. So what is the distance that it is from the ground? It's as simple as 5 minus 1.25. So which gives us the final answer, nothing but 3.75 meter from the ground. So basically it is more important for us to find the time that the second drop has traveled by the time the first drop has reached the ground. So once we find that, rest of the things are quite simple and we can get the answer. So this brings us to the end of this topic, and the upcoming topic will be on the topic 13 for class 9 foundation, where we are going to discuss additional problems on motion. So let's be there, keep subscribed and share this video to motivate me more. Thank you for your support. Thanks all.